Welcome back to video notes on 4.3. Now we're getting into the counting rule for combinations. So the number of combinations of n items taken are at a time. So the difference between a permutation and a combination is in a combination, order does not matter. 1, 2, 3, 4 is the same as 3, 2, 4, 1 is the same as 4, 3, 2, 1. That's the same combination of four numbers. Permutation, that order is a difference. So if we want combinations of n things taken r at a time, this is the way you check it in your calculator. It's n factorial over r factorial times r minus n, or n minus r factorial. So in this last example here, we're going to determine, is it a combination or is it a permutation? And then apply the correct formula. So there are 17 students in a student council. They will elect a president, a vice president, and a treasurer. How many different slates of officers are possible? Okay, well, if there's a president and then a vice president and then a treasurer, and then I do another order of those, this order matters, whether you're president or vice president or a treasurer. It makes a difference which order you're elected in. So this is a permutation. So this is a permutation of 17 students choosing three possible orders of slates. So that's going to be 17 factorial over 17 minus 3 factorial, which is 17 factorial over 14 factorial. Now remember, 17 factorial is 17 times, 16 times 15 times 14 factorial, which will go all the way down to 1. The reason why I stopped there is because my denominator already had 14 factorial. That'll cancel out. So it is 17 times 16 times 15, which is 4,080 possible slates. So let me go ahead and double check that with my calculator. Math, probability. This is a permutation because the order in which they're elected matters. We had 17 students choosing three possible positions, and we have the same answer. All right, let's look at part B. 4 student council members are going on a conference trip. How many different groups of 4 could possibly go? Well, if, let's see, Alice and Johnny and Chris and Matt go, that's the same as if Matt and Alice and Johnny and Chris go. I might have already forgotten the names I said. So this is definitely not a permutation because the order in which the students are in a specific group does not matter. So this is a combination of 17 possible students choosing 4 for each group. So that's going to be 17 factorial over 4 factorial times 17 minus 4 factorial. So that's 17 factorial over 4 factorial times 13 factorial. So let's see. I'm going to do this by hand first, then check with the calculator. 17 times 16 times 15 times 14 times 13 factorial over 4 times 3 times 2 times 1 times 13 factorial. My 13 factorials will cancel. So in my calculator, I'm going to plug in 17 times 16 times 15 times 14, parentheses, divided by my denominator, 4 times 3 times 2 times 1, which is 2,380 possible combinations of 4 students you could choose out of that 17 to go on the trip. Now let's check with my calculator. Math, probability. This is a combination. 17 choosing 4 possible students, groups of students. Perfect answer. So we will be practicing the counting rule, permutations, and combinations in class.